Good day. Welcome to our lesson. On this lesson, I'll be focusing on calculus, which is for grade 12s. So if you are new to the channel, please go through other playlists where we've covered all other topics. So, and also if you are new, please subscribe and also share and also comment if you've got different type of questions that you might want us to try. So without wasting any time, let me go straight to the lesson. So on this lesson, I'll be showing you guys how to do the derivatives. So first thing first, I'll just focus on some few laws or few ways you can derive something. So normally, when we're dealing with functions, they tend to give us a function. It can either be fx, or you can get it as gx, or you can get it as hx. They normally use any notation, but mostly it's fx. So if you're given that function as fx, when it comes to derivatives, we tend to put a symbol like this, which is like a 1 there. So that symbol there represent what we call a first. That symbol there will represent what we call the first derivative. So meaning we're no longer at fx now, we're at the first derivative. Whenever you see that symbol like that, it means first derivative. Don't confuse that symbol with f minus 1, for example. So whenever you see f minus 1, that is mostly for what we call inverse. It's mostly for inverse graphs. But when it comes to f1, that is your derivative. So don't confuse the two, because sometimes learners can confuse the two. For that, sometimes you're given f with that 1 there, and then sometimes you're given f minus 1. They're two different topics. So in our topic today, we'll be focusing on this one, which is the derivative. So let's say they give us a normal function like fx is equals to maybe 4, for example. So if your normal function is equals to 4, or any number, can be negative 10 or negative 50 or 1000, whatever, always know with this first law that I'm going to show you, the derivative of any number or any constant, which is a number, is equals to 0, meaning that the derivative of 4 will be equals to 0 as your answer. So the derivative of any number will always give us a 0. Same thing applies, even if it's negative 50, for example. Same thing, the answer will be 0. The derivative will always 0. That's the first law that you guys must know. The derivative of any number is equals to 0. That is our first law that you must know for grade 12s. Also for those ones who are in college or varsity. Now, the second one that I want to go to, I'm going to put number 2 there so that you guys can be with me, right? So if now, let's say I'm given fx now again. Now I'm given fx again. But this time around, let's say I use 4 again. Let's say now I'm given 4x. Let's say they give me 4x. So now, with the second law, the first derivative of a number that is attached to a letter, like 4x, for example, is equals to that number. Meaning the answer will be 4. So your first derivative answer will be 4. So same thing. If tomorrow they're giving me fx, let's say it's negative 10x, for example. Let's say we're given fx as negative 10x. Therefore, the answer will be equals to negative 10. So the derivative is equals to the number that is attached to your x there. So meaning the answer will be negative 10. So always remember that if it's fx is equals to 20, for example, then therefore your answer will 20x, for example, your answer will be equals to 20. But if your fx is equals to 10, then the answer will be 0. So as long as it's attached to an x, the answer becomes that number. But if it's a number, the answer becomes 0. But remember, that is only for the first derivative, because we can do other derivatives as time goes on. So that's the first 2 laws that you must know for grade 12. The third law is the most common one that you're going to use a lot in grade 12. Let's say now they're giving us a number, let's just call it n, and also x. So now we're given two different numbers. So if we're given a number like this, second law will apply. Remember, the answer will be n, because fx will be equals to nx. Therefore, your answer must be equals to n. But now, let's say tomorrow they're giving us an exponent. Let me say instead of using fx, I'm going to use y now. Let's say I'm given y is equals to x squared, for example. Y is equals to x squared as my normal function. So to solve this type of problem, if you have to find the derivative, so therefore the derivative, you can either use dy over dx, because I'm doing a derivative of y in terms of x. Mostly this applies to those ones who are in college or varsity. So same thing will apply. If it was fx, it would be f1 for fx, but if it's y, you always do dy over dx, because I'm doing dy on terms of x. So now the first thing that you must always do, you take the exponent down, which will be 2 in this instant. Then you multiply your exponent by the letter, which is x. And then the second step, your exponent, you minus it by 1. That's the how to do the derivative. So meaning if we were to simplify this, this will be 2x to the power of 1. This will simplify to 2x to the power of 1, which is the same thing, because remember, if we are given to the power of 1, we'll just leave it as 2x, because the same thing as having the power of 1, the number will come back as 2x. So that's the third law. So if you want to use letters, we can use letters like this, because I know some learners will be like, hey, let's use letters instead of using numbers. So if you have to use letters, for example, let's say they give us x to the power of n. Let's say they give us x to the power of n. So therefore, using the third law, my answer will be n times x, and then will be the exponent, which is n minus 1. That is the third law of derivatives. So let's use an example, which is a bit different this time around. Let's say now I'm given y is equals to, let's say 3x cubed. Now let's make a bigger number, 3x cubed as our given function. Therefore, our answer will be dy, our derivative will be dy over dx, because I'm doing derivative in terms of x. My answer will be dy over dx will be equals to, same approach applies. Remember, first thing first, the exponent will come down. So the exponent will come down. So I'll zoom in there so that I can just make it a bit. So the exponent will first come down. So meaning it will be that exponent, which is 3 times, remember, the base there, which is 3x as it is, and just multiply them as they are. And then to the power, remember the exponent is 3, but you must minus the exponent by 1. Meaning my answer will be 3 times 3, which will be 9 x squared as my derivative. So my derivative will be 9 x squared for that one. So that's how you will be able to simplify that type of question. So first thing first, exponent comes and multiply the number at the base, and then second step, the exponent minus 1. That's the third law of derivative. Let's just do one more example, which looks a bit different. Let's say now dy, so let's say we're given y is equals to 4x squared now, because there was 3, so I want you guys to be confused by 3. Let's say I'm given 4x squared now. Let's say now I'm given 4x squared, and then the same thing applies. The one has to find the derivative, which will be dy over dx. So we know that the first thing, the exponent must come downwards. So meaning for this one, we know it will be 2 times 4. So it will be 2 times 4. 2, so exponent times 4, and then 2 minus 1. That will be our answer, which we know that 2 times 4 will give us 8. So it will be 8x to the power of 1, which can come back as 8x. So my answer would be 8x as my derivative. So yeah, those are the three laws that you guys need to know for grade 12s, and then the other laws like your quotient rule, your chain rules for those ones who are at college or university. So quickly also, I also want to do another type of method now. Let's say they're also giving us a square root now. So if they give us a square root now, the game can change a bit. If I'm given a square root, for example, a square root of x now, first thing that you must always do when you're given a square root, you need to change that or convert that given number to an exponent. So mostly with square roots, if you're given a square root like this, even though they don't put it down for us, there's always a 2 outside there. Even though they don't put it for us, but there's always a 2 outside. And we know by exponential laws that if there's an x, there's a 1 that is there. So to remove that square root, we will take the x as it is. The 1 that is there will then divide by the number which is there after the square root. So it will be x to the power 1 over 2. That is how you change that square root. So same thing, if tomorrow we're given, let's say they're giving us 3 there, and then they're giving us x2 ne? So they give us x2 for example. So therefore to change this, we're gonna simplify it to x, then 2 over 3 now. Because remember it's always the exponent divided by the number outside, which is 2 over 3. That will be how you will change that. And don't forget, this is us changing, but this won't be our derivatives. For me to get the derivative, I must use the third law. Ne? So third law, we know it must be exponent times the base, which is x, and then exponent minus 1. That will be your derivative. Ne? So you need to go and simplify it using the calculator, which we know it will end up as half to the power of negative half x to the power of negative half. Ne? So my final answer will be that to the power negative half as my derivative. That will be my final answer as my derivative. So that will be you simplifying that one. Same thing must apply with this one. We just changed only there. So you must continue and get the derivative. So it must be 2 over 3 and then x, then 2 over 3 minus 1. And then just go and simplify the answer. That will be your final answer as your derivative. Then that will be us doing the ones which involve the square roots. Ne? So the last one I'm going to quickly go through are those type of questions which will involve fractions. Ne? So if we're given one, let's say we're given a number that involves fractions. Let's say they give us 1 over x to the power of 2. Ne? So we're given a fraction now. Again, same thing applies. Before I can do the derivative, I must first convert this to an exponent. Ne? So whenever you're given like this, you always take the number that is denominator as it is, but when the number goes up, its exponent must change its sign, meaning to come back as x to the power negative 2. That will be you changing it, and then from there onwards, the derivative will be negative 2x, negative 2x now, then negative 2 minus 1. So that will be our derivative answer. So just need to go and simplify it, because that will be giving us negative 2 to the power minus 3 as your final answer or your derivative answer. So always remember that when you're given square roots, first convert them. Same when you're given fractions, first convert them. Then from there onwards, you can do the derivatives. Then that will be you solving any type of questions that involve this type of solutions. Last one quickly. Let's say now they're giving us a number like this. Let's say they've got giving us x to the power of 2, for example, and then plus x, for example, and then plus 1, for example, and then the whole thing, they're dividing it by, let's say they divide the whole thing by x now. So when you're given this type of question, the quicker way to do before you do the derivative is to divide all the numbers by the denominator. So meaning it will be x squared divided by x. Same thing, x divided by x, and then 1 divided by x. Then from there onwards, you can just simplify as much as you can. It will be x over x. Then from there onwards, you can simplify again, and then you can do